By learning about the history of mathematics, I'm sure that you are convinced that mathematics, in every form that we know today from school and college, although we might feel it is useless, was born to solve a particular problem of those days. In this section, I want to extend on this and show you where the various components of mathematics are used in real life or daily life. My grievance against the current pedagogy of teaching mathematics is that they start from teaching the definitions, rules, classifications, and theories. This, as I have been telling you many times, is the one quadrant approach, namely that of the lower left brain or the scale brain quadrant. It works for some students, but for most, it's a turn off. The problem with this single brain approach is that the student can't fall in love, let alone appreciate mathematics. So, as per the four brain learning approach, I began this chapter from the information quadrant or the lower right quadrant. People dominated by this part of the brain are very practical and emotional people. They want to be able to relate to whatever they are studying. The sad thing about the syllabus of today is that the student will be taught the real life applications of mathematics, but only when they reach their bachelor's degree and master's degree. That too, they would be taught in their particular subjects. So, somebody who is studying mechanical engineering like me will not be taught how math is used in economics and vice versa. Then the more obvious uses of mathematics is left for the student to discover or identify by himself. However, most students are not driven by self-discovery or self-study. So they will not make that effort to find out where the math is used in real life. And this is the reason I have written this section. You can see the table in the diagram. It consists of 13 components of mathematics, which will be a recurring format for all the upcoming sections. Those 13 are just an expansion and continuation of the knowledge tree of math that we had talked about earlier. I wanted the student to be able to visualize in one single view everything that math was. My objective throughout this chapter is for the reader and student to see both the trees and the forest at the same time. It has been a painstaking and meticulous process for me to develop those diagrams, but I'm highly satisfied knowing that one day, through one of you, my readers, they will serve millions of students to love and appreciate mathematics the way it was meant to be. I'll be talking about the real life application of each of the components one by one, but at first, I would like you to have a general and complete picture of those 13 components within a few hundred words. First, let me just list out the 13 components so that it can fill your temporary memory. The first one of the component are the numbers, as you can see in the diagram. Without numbers, math doesn't exist. Like without the alphabet, language doesn't exist. Then we have the various operators for comparison and grouping. Two entities are either equal or greater or smaller than one another. The parentheses, the brackets, and the braces help us to sequence various mathematical operations. The third component consists of the plus and minus, or addition and subtraction, followed by multiplication and division. The fifth component in the table consists of fractions, ratios, and percentages. These are ways to basically cut the pie into pieces. Then the sixth component is the compound interest or exponentials. It's a very unique and important relationship between two variables. The seventh component is the set theory. What's common between two groups? Who is the odd one out? These are some answers, set theory answers. Then, to end all the components with regards to arithmetics, I have placed mental calculations versus the calculator. We don't need usually to find the exact answer to say 99 multiplied by 99. This is what this component is about. That is to approximate this expression to 100 multiplied by 100, which is much easier. Then the ninth component is geometry, or the math of shapes. Then we have algebra, which we have discussed as about finding values of a parameter based on a relationship with other known parameters. In my list, I have placed combinatorics in the 11th number. This talks mainly about combinations of various items. Then in the 12th component, I've placed trigonometry, which is all about triangles, as we have talked earlier. Then finally, the 13th component is calculus, which is about finding the rate of change and area. So now you are able to play the 13 components in your mind in one shot. Forgive my lack of accuracy in this section, but my intention was just to make those 13 components stick in your mind. Quickly, I will again replay those 13 components and try to express a world without that particular component. At some point, it might sound ridiculous, but as I told you, my intention is just to help those 13 components stick in your mind and not taking them too seriously. That's the beginning of loving and appreciating a subject. If there was no numbers, then we would not know our own age, I guess. Nobody would be rich or poor, then the rest of mathematics wouldn't have existed. It might be a good news for some of you, although. If the second component consisting of the various operators didn't exist, then we would have no ways to compare, group, and have sequences. We would never be able to say what is equal to what and what is greater than what. That could be a problem. If we could not add or subtract and we always had to use our fingers, that would be very cumbersome. It would even be worse if we had to use our fingers or grains of rice to multiply and divide. If we did not have fractions, then we'd never be able to divide the pizza and make rations among friends and siblings. Without percentages, we would not be able to compare one thing with another. Without the knowledge of compound interest and exponentials, we'll never have been able to understand how population growth occurs and what it means to make a 0.1% improvement per day for the rest of your life. By the way, it means a gigantic number by the end of one's life. Without set theory, we will not be able to make proper analysis of anything. Without the ability to do mental calculations, we would always be dependent on the calculator, and we would be a target for cheats. Without geometry, we would not have a house, and travel would have been impossible. Without trigonometry, there would be no truss in our roofs, and even if we somehow build a structure, it would fall by its own weight. Finally, without the 13th component of calculus, as per my list, we would not know about gravity itself. So this completes my second run of the 13 components. Before I begin my exposition for each of the 13 components and their use in daily life. Again, I repeat, the above paragraphs were intended only to help you recall those 13 components and not to take them too seriously. I repeat, math can be fun. It is not as vast and infinite as the syllabus in school and colleges have been trying to tell us. All of mathematics can be summarized in that single diagram. Even if you do not want to actually solve mathematical problems, you will be able to see how they are used in real life, and mathematics will still be your best subject.